So in a quadratic equation, when we talk about the short run behavior of a graph, what we really care about is the vertex, which helps us to determine where is my turning point from where the parabola increase, decrease, or where the parabola decrease and increase. So that's why we care about the vertex. We also care about the zeros of the function, meaning my x-intercept and my y-intercept of the graph. So these what we call the short run behavior of the graph. What's happening with the graph where we are able to obtain. Now the long run behavior of the graph is what happens as my x values go to infinity. For instance, if I have a parabola function, my short run behavior of the graph is the vertex right here, where my x-intercept as well, where it crosses the x-axis, and my y-intercept, where it crosses the y-intercept. And we also care about the long run behavior as my x values go to negative infinity. What is happening to my function? And what happens as my x value goes to positive infinity? So when looking at the short run behavior of a parabola, when we talk about the intercepts, the horizontal intercepts, meaning my x-intercept, we notice right here when my graph is upward where it doesn't touch the x-axis. So that's when we say that we have 0 horizontal intercepts. And then we have 1 horizontal intercept when my vertex is the point that is touching my x-axis. We would have 2 horizontal intercepts when it touches the x-axis twice at 2 points. So a parabola or a quadratic function either has 2, 1, or non-horizontal intercepts depending on the graph and the transformation that's happening with the graph. So going back to this function, let's find our short run behavior of the graph. Since this is in vertex form right now, I know that my vertex point, which is h, comma, k, where right here h is equal to 3 and k is equal to negative 4. So I know that my vertex point is at 3, comma, negative 4. So now also my short run behavior of the graph is finding my y-intercept. So to find my y-intercept, I need to set x equals to 0. So f of x is equal to 0 minus 3 squared minus 4. So now here, using order of operations, I take care what's ever inside the parentheses. So 0 minus 3 is negative 3 squared minus 4. Then I take care of the power. So negative 3 to the power of 2 gives you 9 minus 4. So 2 times 9 is 18 minus 4 gives you 14. So my y-intercept is 14. So that means it's 0, comma, 14 for my y-intercept. Now to find the x-intercept, I set y equals to 0. So now here it's 0 equals to x minus 3 squared minus 4. So now right here, my x is only in one place. So I can here just do the order of operations to solve for x. So I add 4 to both sides. 2x minus 3 squared. I divide by 2. X minus 3 squared. Now to get rid of this power of 2, I square root both sides. And that gives me x minus 3. Now remember, the square root gives you a plus and a minus outcome. So now the last step is adding 3 to both sides. So 3 gives you 3 plus or minus square root of 2 is equal to my x. So at these two values, I have my x-intercepts, which I can just rewrite as 3 plus square root of 2 and 3 minus square root of 2. So my y-intercept is 0, comma, 14. My x intercepts are 3 plus square root of 2 comma 0 and 3 minus square root of 2 comma 0. So now right here I have all my short run behavior of the graph. Now something extra we need to consider is where's my graph increasing and where's my graph is decreasing. So when I have my vertex point, which is 3 comma negative 4, so let's draw this graph on a coordinate point. So right here I graphed my function and I know that my vertex is at 3 negative 4 and I have my x-intercepts right here. And from here, my vertex, I know that my graph is decreasing from negative infinity up to 3 and it's increasing from 3 comma infinity. So my x value of my vertex, which is 3, is determining where my graph is changing from decreasing to increase.